I want to make one quick announcement. I have been grading your tests. I have one more page left to grade. So what I do is I grade everybody's page 1 and everybody's page 2 and everybody's page 3. So I don't know how people are doing individually because I don't look at names as I grade. It's just a way for me to keep the partial credit consistent from test to test. So they will be graded and entered into the Moodle grade book certainly tomorrow at some point. I will hand them back in class on Friday. Okay. So definitely be prepared to get the test back on Friday. You know, I would say in general, so far people are doing well. Yeah, I mean, we'll look at totals at the end. What I will say is that the way I curve tests, if there is a curve per se, is I take the top score in the class and make that the perfect score. So if the top score in the class is a 95, I'll just add 5 points onto everybody's test. Then additionally, if someone gets like a perfect score and then the next high score is in the 80s, obviously I can't really do that because, you know, there's a huge gap then. I don't think that's what's going to happen here. I mean, it's super easy to get nickeled and dimed on math tests, but, you know, in general, I really feel like a lot of you have a pretty solid understanding of what's going on. And anyway, so I just want to let you know that I got a fair amount of grading done, and I just have the last page of everybody's tests to get through. It was a beautiful afternoon, so like I split from my office as soon as I could yesterday after my last meeting, and I'm like, I'm just going to sit outside in the grass and grade papers. So that is what I did. Anyhow, again, we'll talk about the test more when I hand it back. And I will post solutions to the test on the Moodle page so that you can look at, you know, your answer versus the answer key and that sort of thing. Okay. The one thing I'm going to say today is I built and structured this class in such a way that no one test is going to mess up anybody's grade. Okay. I do that intentionally. You know, there's these things called formative assessments versus summative assessments, and that's getting in deeper than anybody in here probably wants to go. But having to take a high stakes test, like a one and done thing, you know, some people are really good at those things and they take a lot of pleasure in those. Some people really struggle with math tests, like a one and done thing. And, you know, unfortunately, our society and our education system is built in such a way that we do need to give those. But I do make a very conscious effort that they won't impact anybody's grades so heavily. So if you're not as good at taking tests, you know, the online homework is worth the same amount as a test. The class activities are worth the same amount as a test. So, you know, again, I have it built so that people can be successful still, even if they're not so great at taking tests. One thing that I'll be very curious to hear from you all is how you felt about having that cheat sheet. You know, did you find it helpful? Was it good to have it there? You know, did you use it? Or was even making it really helpful in order to help you prepare for the test? You know, I'll be curious what various people's takes are on that as well. All right, so yeah, anyone have any comments, questions pertaining to what I was talking about or something totally different? Okay, well, are you all doing okay today? Are your classes going well? Good, good. I'm not asking that sort of thing to be nosy. I'm not really a nosy human being. I just care. Like, obviously, I care how you do in this math class because this is what we do together. But like, I think it's important, you know. The last thing that I want to say is this. If you need math help, number one, I'm a really good resource. I've been at this for a long time. And I usually have pretty good ideas to what sorts of things you're going to see on your tests, given the fact that I write them. And also, you know, what sort of material you're going to need to understand really well going into a statistics course, if your major requires a statistics course after this. So, you know, I encourage you to get help with me. The Math Learning Center over in the math building on the Mountain campus has free walk-in tutoring every day from 10 to 6, Monday through Thursday. And then on Fridays from 10 to 1. Make use of that resource. They're awesome. They do a really, really good job. And the tutors there are super, super good and helpful. I know a lot of them. They're math majors. Some of them are math grad students. I definitely recommend you take advantage of that. I mean, if you want to just make a habit of doing your homework over there, cool, do it. But I also want to add that if anybody in the class is struggling in other aspects of, you know, whether it's being a student or other classes or things going on, I'm happy to meet with you. Like, I want you to know that I care about you just beyond this math class. Like, I want you to be solid and to be doing okay. And I know that fall semester in college can be a struggle for a lot of people. I mean, so please know that I'm available and that I'm happy to talk with you. So, cool. All right. So, did you like what we did yesterday? The enthusiasm is just amazing. Yeah, so that was really cool. We learned a new magic word. I mean, we've been talking about and or, but now we have another 2-letter word that is really significant. If. Okay, so we talked about that yesterday in terms of a table. We talked about that yesterday in terms of a Venn diagram and in terms of general probability. What I'm now going to do is focus on tree diagrams. Okay, so some people on the test mentioned that they still felt a bit funky about trees, at least tree diagrams as they pertain to this class. And don't worry, we're going to delve in a lot deeper and really bring all of that material together at this point. Okay. So what I'm going to do is put up a stupid story, and we're going to construct a tree diagram together and answer some probability questions. A couple of those are going to follow very much with what we did, what you did on the test on Monday. But then we will also take things a little bit further, and then I'll generalize, and then I'll do more examples. Okay. And then we have one little part left to cover in this section, and that's on what we call independence. So we'll get to that. Not today, Friday. Cool. Awesome. Last but not least, the last thing I want to say for right now pertaining to the test is showing your work is a beautiful thing. Okay, So for example, like on number 2 on the test, you know, constructing a Venn diagram was one way to solve it, or using the union rule. You know, even if you got the wrong answer, but you showed that you went about it using one of the ways that we did to solve these sorts of things, you would get partial credit. So definitely be sure to show your work, because if you just write some number answer and it's not correct and you don't show any work, then I can't give you any credit. So it's definitely to your advantage. Okay, ready? Okay. Okay. Of all of the people applying for a job, 75% are qualified. A personnel manager approves qualified applicants 85% of the time, and approves unqualified applicants. Like, why would they even look at an unqualified applicant? That's beyond me. 20% of the time. So the first thing that we want to do is we want to draw a tree. Okay. Now, going back to what we talked about prior to taking the first test, remember these trees will have a couple of branches, and the second branch has that conditional probability. Okay, so that percentage or probability depends upon that first event happening. Okay, so if you had to construct a tree on your own, the first step is figuring out what is my first branch versus my second branch. Okay, and what do we have going on here? We have a couple things going on. One of them is whether or not people are qualified. Do you agree? Okay, and then the other issue that's going on here is whether or not they're approved. I claim that one of those things depends upon the other. Okay, in fact, in this particular example, I claim whether or not somebody's approved, or the likelihood that they're approved, depends upon whether or not they were qualified to begin with. Do you see that kind of from this statement here? Okay, so my first branch is going to be qualified or not qualified. And then I'll have my second branch be approved and not approved. What percentage?
Hey, Lauren,
Yeah.
is it wrong if we put the qualified on top of the branches and the probability where you put the Q?
No, I mean, this is in general the way we tend to write them, and then we put the probability right here.
Okay, cool. Thank you.
No, thank you for asking. You're cool, Michael. Thank you. All right. So what percentage of the applicants are qualified? 75%. We tend to write these in decimal form here, so I'm going to write 0.75. Well, if 75% of the applicants are qualified, do we know what percentage of the applicants are not qualified? Yeah, totally. What is it? 25%. How do you know that? Because they have to add up to 1, right? Either you're qualified or you're not qualified. There's really no in between. Now, the percentage or decimal that we put here is if the person is qualified, what's the likelihood that they're approved? And what is that? 85. Okay, well, again, if the person's qualified, either they're approved or not approved. And if 0.85 are approved, what do I have as not approved? 0.15. Again, each of your branches have to add up to the total of 1. You with me this far? Okay, well, if the person is not qualified, what's the likelihood that they're approved? 0.2, and therefore, what's the likelihood that they're not approved? 0.8. You with me this far? Now, if constructing the tree, like figuring out first branch, second branch, is a little difficult, that comes with practice, okay? You with me this far? All right, so I'm gonna go through and say some words here because there's some verbiage that I use and I want to be sure that we're all on the same page. I'm very literal. I call this part my inner branch and I call this part my outer branch. Okay, these aren't formal terms, but do you agree qualified, not qualified? It's inside my tree here. Whereas out here, this is outside of my tree, like literally speaking. Do y'all see where I'm getting that from? Okay, just want to be sure because I'm going to be using that quite a lot. So let's suppose that a person is selected at random. And we want to find the probability that how about the person is qualified and approved? Now, I claim that this is similar to something that you had on your test. Okay, what are we wanting? We're wanting the person to be qualified and approved. So I'll write Q and A. What does and tell us in terms of operations? Multiply. So do you all agree that we want to find the probability of this branch here? And how do we find the probability of a branch of a tree? We multiply across the branch. You with me this far? All right. How about finding the probability that the person is not qualified? Where is that on my tree? Isn't that right here? Not qualified? Okay. Do we know the probability that the person's not qualified? Yeah, what is it? 0.25. Right now, we're practicing also with doing these computations as well as reading the tree. All right, what if I want us to find the probability that the person is approved? I claim you had to do one similar to this on the test as well. Notice we want the person to be approved. Do you agree they can be approved this way as well as this way? But this 85% is dependent upon the fact that you picked a qualified candidate to begin with. And this 20% is dependent upon the fact that an unqualified person was picked. So what we want to do is ask ourselves, well, how can a person be approved? Okay. With a straight up probability question, you can't just look at your outer branches and say, well, it's 0.85 plus 0.2, because you're going to get a probability greater than 1. And then the math cops are going to come and take you away. Okay. And while that means that you get to sit and do math interminably, it's not outside, so it's not desirable. Okay. So how can a person be approved? Well, I claim that they could be qualified and approved or not qualified and approved. Do you kind of sort of remember this from what we did before? I think the reinforcements are always helpful. Okay, well, qualified and approved is 0.75 times 0.85. What does OR tell us? Plus. So how about not qualified and approved? What do I get there? 0.25 times 0.2. And not that we really care what the answer is, but that's what you get. So part A and part C are similar to what you did on your test. All right. So now what I'm going to do is introduce a couple more questions. What if I want to find the probability that the person is not approved if they are not qualified? What's the magic word? If, right? Okay, so once we see that there's a conditional word, remember from yesterday, you always reduce your sample space down to whatever event immediately followed that conditional word. So aren't we reducing our sample space down to those who are not qualified? So aren't we already right here? Okay, well, if this is now our starting point, do you agree, using my inner and outer, what we're doing is we're assuming the inner and want the outer, right? We're assuming they're not qualified and we want the probability that they're not approved. Do we know that? Yeah, that's just 0.8, right? If we're already right here, remember, these are conditional probabilities. This is the probability that they're not approved, given that they're not qualified. So you can just read it straight off the branch. All right. So notice on this one, we were assuming the inner branch and we wanted the outer branch, and we could just read it off the tree because these are conditional probabilities. So the big question comes, what if we're assuming the outer branch and we want the inner branch? In other words, in this case, let's find the probability that the person is qualified if they are approved. First thing I want you all to notice, we have a conditional, okay? You want to look at the wording first and foremost, because that gives you a wonderful hint as to how you're going to go about solving it. Okay, again, we have a conditional. So what we do is we say, we need to reduce our sample space down to all the folks who are approved. Do you agree now that we're assuming the outer branch? And in this case, we want the inner branch. Okay. So I'm going to write assuming outer, want inner. So we need to reduce our sample space down to those who are approved. Do we know that yet? I claim we actually did find that. Didn't we already find the probability that the person is approved? Okay. So what we do is we say, well, reduce our sample space down to those who are approved. In other words, they could be qualified and approved or unqualified and approved. Do you agree we've reduced our sample space down to these two branches? Right? We're assuming that they're approved. Okay, so you reduce your sample space down to being approved. Well, how can they be approved? Qualified and approved or unqualified and approved? We've reduced our sample space down to these two possibilities. One of these is what we want in our numerator. What are we interested in this particular question? Them being qualified or not qualified? Qualified. So you would put this branch in your numerator. So you get 0.6375 in your numerator. In your denominator, you have 0.6875. So we say that there's about a 93% chance. All right. So one of the things that you're going to see is that our tree problems follow the same basic process. Okay. The key thing, and don't worry, I'm going to be doing more examples like in just a moment. The key thing is you have A complement, and then B complement, B complement. Okay. You can be asked to find the probability of a branch of a tree. Like you can be asked to find the probability that A and B happened. And then you would just multiply across that branch. You can be asked to find the probability that one of the things in the outer branch happens. Note, there's no conditional listed here. So if you just want to find the probability of the outer branch, what you have to do is consider both branches. Then you have to do A and B or A complement and B. You could be asked to find the probability of B if A happens, and then you can just read it off the tree. Notice if we're assuming the inner branch and we want the outer branch, you can literally read it off your tree. And I always put a little smiley face because it means that we don't have to work very hard. And that's always kind of a pleasure. But if you want to find the probability of the inner branch, so I'll put outer if inner, and then inner if outer, that's when you need to actually do more work. If you're assuming B happened, you have to put all the ways B can happen. And then put whichever one of these two in your numerator you're interested in. So do you remember how with our Venn diagrams yesterday, we would first reduce our sample space down to the two regions in the Venn diagram that we were left with, and then we picked one of those? We're doing the same thing here. Okay, it's just a little funkier looking. All right, so what I want to do is take another example or two. Sound good? Y'all seem so tired. I'm sorry if this class is boring for you. I try to make it as exciting as I can, but yeah. Okay. I could be boring, but thank you for saying that. Okay. Well, it's always really hard. I'm just going to say this really quick. I love math, right? Like, this is like my thing. I love math. You know, I wake up in the morning and I see that people have submitted questions to me on My Open Math. And I'm like, yes, I get to drink tea this morning and answer math questions before I go for my run. And that's like an exciting thing in my life. I love this, but I also realize so many people hate math so very, very, very much. And anyway, so it's always kind of a struggle because it's like, I want you to see that this is at least a little bit kind of sort of cute, even if you end up not loving it. And it's always like, oh my gosh, I teach the course that everybody has to take but doesn't want to take. And anyway, so the struggle. So let's do this. A survey was given on whether, this is a silly one, people like a particular hair product. I guess it's just silly for me because, like, look at this. Okay, so suppose 55% of the respondents to this survey were students. And the rest were staff members. Of the students, 83% liked the hair product. Whereas 92% of the staff liked it. All righty. You ready? Hooray, let's draw a tree. So, which branch comes first? Notice we have a lot of numbers here, okay? So I want to try to help you think about how to separate them and figure out what order things go in. Do you agree that we've got two things happening? One is whether or not it's a staff or a student who responded. And then the other one is whether or not they like the hair product. You with me there? Which depends upon which? Beautiful. Notice of the students, this percentage liked it. Okay. And of the staff, this percentage liked it. So my first branch is going to be student or staff. And then it's like or not like. Do I have these values? Heck yeah. What percentage of the respondents were students? 55%. Therefore, if everybody else was a staff member, what does this have to be? 0.45, isn't it 1 minus this? Of the students, what percentage liked the hair product? 83%. So all the other students didn't. So 100% minus 83% is 17%. Of the staff members, what percentage liked it? 92%. Therefore, what percentage did not like it? 8%. Notice when you put 8% in decimal form, it's 0.08. Don't put 0.8. Just saying. Now, on the tests, typically the tree will already be drawn for you and filled in, but you will have to draw a few trees on your online homework. All right, so let's answer some absolutely thrilling probability questions about hair products. So a person is selected at random. Find the probability that, part A, the person, well, let's start chill, was a staff member. Where is that on my tree? And just give a guess. You know, it's cool to be wrong, right? Making mistakes is the most important part of learning. Okay, isn't the staff member right here? See, staff? Do we know the probability that they're a staff member? Yeah, so it's 0.45, and I'll smile there. Now, on the other hand, what if I want to find the probability that the person was a staff member who liked the product? Now, don't we want them to be a staff member and like the product? Okay, the most important thing you can get here is to start noticing patterns with how we're solving these. Well, staff member and like the product, you would take 0.45 times 0.92. You with me there? All right. So what if I want to find the probability that the person liked the product? So pattern-wise, notice, initially we were just asked the probability of the first branch. There was no conditional, it was right there. The second one, we were asked to find the probability across an entire branch, staff and like the product. So we multiply across that branch. This third question here, what we want to do is find the probability of this outer branch. Notice there's no conditional word here, is there? Okay, so when you want to find the probability of the outer branch and it is not conditional, you got to consider the whole branch. So they could be a student and like the product, or a staff and like the product. Student and like. What do I compute there? 0.55 and tells me times like is 0.83 or plus, how about staff and like? 0.45 times 0.92. So the moral here is when you are asked to find the probability, and I'm writing this just as a hint for you to have in your notes. If it doesn't help you, obviously don't write it. Of the outer, and there is no conditional given, you need to consider the entire branches. Right? You can't just combine 0.83 and 0.92 because you're going to get a probability greater than 1. All right, I have 2 more questions left to do, and then we'll call it good for today. You ready? Okay, so, and you better believe these are both conditional because I haven't gotten there yet. What if I want you to find the probability that the person liked the product if they are a student? What's my word here? If. Good. So we reduce our sample space down to the event that someone is a student. Aren't we assuming we are right here? Okay, we're already right here. So do we know then the probability that the person liked the product? Yeah, it's 0.83 and we smile. Again, when you're assuming the inner and want the other, you're really in the best situation in terms of the amount of work. All right, what if I, on the other hand, want to find the probability that the person is a staff member if they don't like the product? Now, who are we reducing our sample space down to? Because we see this word. Okay, remember you reduce your sample space down to the event that immediately follows your conditional. So we're assuming that the person doesn't like the product. And in this case, we want to find the probability that they're a staff member. Well, how can a person not like the product? Remember, when you're assuming the outer and want the inner, you have to take both outer branches in your denominator. Well, they could be a student and not like it, or they could be a staff and not like it. And now that we've reduced our sample space down to these two scenarios, we have to pick which one of these two are we interested in. Are we interested in them being a student or a staff? Staff. So you put the staff branch up in the numerator. Now, one comment that I want to make, I didn't bring my calculator today, but when you're doing these computations, this, by the way, is called Bayes' theorem. If you want to look in your book at the formula that they give you for Bayes' theorem, go for it. You're not going to like the way it looks. I think it's better just to kind of logic it out. But what I want to say is when you're doing the computations, do not just enter this entire strand into your calculator. You will not get the correct answer. Why didn't we do that for like if student? Because we didn't do that for like if student because we were given those probabilities. When we're assuming the inner branch, we know what the probability of the outer branch is. Okay, so we're given the probability of the outer if we're assuming the inner. It's just if we're assuming the outer one, finding the probability of the inner. But the comment that I want to make here real quick is compute your numerator, get a number, compute your denominator, get a number, and then divide. Because your calculator knows its order of operations, and otherwise it'll do this divided by this and add this on at the tail end. We'll continue this Friday, and I'll also hand back the tests on Friday. Have a great day, friends.